Now, coming to the next example. Let me take sodium tetrathionate. You know the formula of sodium ion is Na plus, right? And the formula of tetrathionate ion is, of course, S4O6 2-, isn't it? We have the list of all the cations and anions. I told you to go through them. Hope you have all gone through. Now, coming to the valency of this. You know the charge present on sodium is +1 and the charge present on this is -2. Coming to valency, as I said, valency is never associated with any sign. So the valency of sodium ion is 1 and the valency of this tetrathionate is 2. Come on, take criss-cross method. So that will be Na2 S4 then O6, right? So that is the formula of sodium tetrathionate. Okay. Now let us take one more example. Go for potassium manganate. See, there is a permanganate, there is manganate. Now coming to the formula of potassium ion, what is that? K plus. And coming to the formula of manganate ion, you know, permanganate is MnO4 minus, but manganate is MnO4 2 minus. Okay. Now coming to the valency of this, it is 1 here. And coming to the valency of this, it is 2, right? Round up the charges. Don't get confused. We are now crossing the valence. So the formula of potassium manganate can be written as, come on, it is K2 MnO4. Of course, taken one time, but say this taken one time need not be written. So the formula is K2 MnO4. Okay. Now, let me take one more. Say ammonium dichromate. If you have already written the formulae of all the radicals, you can just check out. You know the formula of ammonium ion is NH4 plus, right? And the formula of dichromate ion is it is Cr2O7 2-, right? Coming to the valency of this, it is 1 and here it is 2. Round up the charges. That's it. Once the valencies are written, forget about the charges, cross the valencies. Now check this out. This is interesting. NH4 taken twice. This is the valence. Then Cr2O7, that's it. Taken one time. That is ammonium dichromate. Okay. Now coming to the other one. Aluminium, say, phosphate. phosphate. Right. See, the formula of aluminium ion is Al plus 3. Right. The formula of phosphate ion is CO4 3 minus. Right. Now coming to the valency. Valency of this is 3. Even the valency of this also is a 3. Now just cross the valence. Okay. So this is Al3 PO4 taken thrice, right? But you can just cancel out 3, 3, 3 ones are 3, 3 ones are 3. You can take the ratio and you can simply write this as AlPO4. Even that is okay. Okay. Next. Now, let us take one more example. Manganese acetate. Manganese acetate. Come on. The formula of manganese ion is Mn2 plus, right? Nothing but manganese 2 is manganese ion. Now coming to the formula of acetate ion. You know the formula of acetate ion is CH3 C double bond O minus. Of course, can simply be written as CH3 COO minus. I've just given the clarity regarding this particular ion. So take the valencies now. Here it is 1. Now come on, round up the charges first. Crossing the valencies. That's it. Come on. See the way I'm writing. Mn, of course. O, C double bond O, CH3 taken twice. This is manganese acetate. Is that right? Next. Go for barium. Hypophosphite. Barium hypophosphite. Okay. What is the formula of barium ion? Formula of barium ion is Ba plus 2. Right. Coming to the formula of hypophosphite, it is H2 PO2 minus. This is hypophosphite. Okay. Now coming to the valency. 2 here, 1 here. Simply cross the valence. What do you get? Pa, of course, taken one time. H2, PO2, taken twice. Right? Next. Let us go for one more. Take the formula of aluminium carbide. Now, the formula of aluminium ion is Al plus 3. Similarly, the formula of carbide ion is C minus 4. Right. Now, coming to their valency, 3 and then 4. See, this is Al4C3, right? Next. One more. Let me take sodium zincate. You know the formula of sodium ion is Na plus. Then the formula of zincate ion is ZnO2 2 minus. Right. The valencies are 1 and 2. Cross the valence. What do you think? Na2 ZnO2. Right. So that is a sodium zinc. So these are all different chemical compounds. See, if you are familiar, if you can write the formulae of the radicals, if you can write the formulae of cation and anion, if you can remember them, of course, it is very easy to write the formulae of chemical compounds. So go through them once again. Now, I've actually got some very interesting thing now. It is, you know, writing the formulae of acids. Let me take 4 examples. After that, let me just tell you the formulae. Of course, they themselves include the formulae. Come on. Supposing if you are asked to write the formula of hypochlorous acid. Now, let me tell you that it can be hypochlorous, it can be hypobromous, it can be hypoiodous, but overall, it is a hypoous acid. You know, in order to get the formula of hypoous acid, what are the things to be taken? Anyway, whenever you are asked to write the formula of an acid, take H plus first. And because you are asked to write the formula of hypoous acid, H plus has to be taken along with the hypoite ion. So the formula goes this way. H plus plus hypoite ion gives rise to hypoous acid. Now, because you want hypochlorous, you take hypochlorite. If you want hypobromous, You take hypobromite. That is how it goes, right? Let us check, you know, H plus. And what is hypoite ion? I mean hypochlorite ion. It is available with us. OCl minus is the formula of hypochlorite ion, isn't it? So it's as usual, write the valence. Valence is 1 here, valence is 1 here. Now come on, take the valence in this fashion. The formula comes out to be H1, then of course OCl1. Now this is the formula of hypochlorous acid. Okay. So whenever you are asked to write the formula of any hypoous acid, generally in case of us acids, we take ite ion, because here it is hypoous acid. I have taken hypoite ion, right? Now let me take one more. Nitrous acid. It's of course very simple. You know, here you are asked to write the formula of some us acid. For that, take H plus and add. Just now I told that for us acids you have to take ite ion. Come on. Let us take ite ion. So the formula here is, you know, H plus plus ite ion is nothing but us acid. Any ite ion. There are many varieties. But now we have to consider nitrite because they are asking the formula of nitrous acid. Come on, H plus. And the formula of nitrite is NO2 minus. Here you need to be little cautious because there is something called nitrate with one more oxygen. Nitrite is NO2 minus, nitrate is NO3 minus, right? Now the valence is 1 here, 1 here. Come on. See, the formula of nitrous acid can simply be written as H1NO21. So the formula of nitrous acid is HNO2. This is how you can make it very simple, right? Let me give you some more. Coming to the formula of sulfuric acid. What I want you to concentrate on is this ic acid. Whenever you are asked to write the formula of ic acid, take this H plus plus 8 ion. I mean, here you have to consider H plus and the sulfate ion. So the formula can be given as H plus plus 8 ion is the ic acid. So if you want as acid, take ite ion. And if you want ic acid, take 8 ion. Come on. Let us take H plus. Let us add sulfate ion. See, the formula of sulfate ion is SO4 minus 2. Sulfite, don't get confused with this. There is a sulfite, SO3 2 minus. There is a bisulfate, HSO4 minus. There is a bisulfite, HSO3 minus. You need to be very cautious. Come on. Now the formula of sulfuric acid can be given as H2SO4. Okay. So that's how you can write formula. Let me take one more. Perchloric acid. Even this also is very interesting. You consider it to be a peric acid. See, to get the formula of peric acid, add H plus to per-8 ion. Because it's ic acid, 8 ion. Because it is peric acid, it's per-8 ion. Very simple. Now let us write the general formula. H plus per-8 ion is nothing but peric acid. Right? Now H plus perchlorate. You know the formula of perchlorate ion is ClO4 minus. Valency of this is 1. Even the valency of this also is 1. Now cross the valencies, you'll get the formula. So it is that simple. Writing the formulae of acids is very interesting. Let me give you some more. Suppose there is something called boric acid. Hope you all know what boric acid is. We generally use it when we play caroms, isn't it? The powder what we pour on the carom board is boric acid, boric powder. But you just concentrate on this. You know, you are asked to write some ic acid. The formula of ic acid can be written simply taking the H plus along with the 8 ion. Let me take borate ion because I'm asked to write boric acid, isn't it? H plus and the borate ion. Now coming to the valency of this is 1. Valency of this is 3. You know, taking the crisscross method into consideration, H3BO3 is what we can write for boric acid, right? Now let us go for oxalic acid. Now again, this is an ic acid, right? Now in this case, we have to consider oxalate ion, nothing but C2O4 2 minus. Coming to the valency of this, it is 1 and this is 2. Okay, so the formula comes out to be H2, C2, then O4. isn't it? Next. Supposing if you are asked to write the formula of acetic acid or say formic acid, because we have already taken acetate ion. Let us consider formate ion now. Right. Again, ic acid. You know the formula of formate ion is HCOO minus. Valence is 1 here. Valence is 1 here. Okay. 1, 1. Come on. This has to be written in this format. First the anion, then the cation. Little bit interesting. Formic acid. Normally we write the cation first and anion after that. But here it is little different. Something exceptional. Okay. Next. We can take sulfurous acid. Here it is us acid, right? Let us consider ite ion. The formula of ite ion, I mean sulfite ion is SO3 minus. So valence is 1, valence is 2 here. Come on. Right. This is how you can write the formula of sulfurous acid. Okay. If this is okay for you, I've got something very interesting for you. That is, you know, you've all got the list of cations and anions, right? Let me tell you one thing. You just take all the cations over here in this format. I mean this way. Take all the cations. Then of course, take all the anions. What all are available with you? This is going to be much more interesting. Okay, you take cations in this format, then anions in this way. All the cations, not just the monovalent, not just the bivalent, not just the trivalent, not just the tetravalent, all, even the pentavalent also. Take all the cations here. Say for example, you have taken a cation Na plus here. And consider, say the monovalent, you write all the cations, mono, bi, tri, tetra, penta. All of them one by one. What all are available with you? Take all the anions, starting from the monovalent. But then go for bivalent, then trivalent, then tetravalent, like that. So take all of them and again, you just make it more interesting. Come on, let me just tell you what to do. you take a very big drawing sheet. If one is not enough, take two. I think one will be better because you have to actually write all the things, and see that you make a table this way. So take all the cations and all the anions. Okay. I hope you got my point. Now, coming to the formula of the chemical compounds, if at all you consider, suppose here you got something else like say hypochlorite, and here suppose there is a bivalent ion Mg plus 2. Now, check the way it has to be written. Come on. The first one will be like this. Na plus and Cl minus. What do you get? So that is going to be NaCl. Isn't it? Na plus 1 Cl minus 1. Now the second one will be, it will be this. What would it be? NaOCl. Sodium hypochlorite. And when you go for the second cation, come on. Coming to Mg plus 2 thing. Mg plus 2 with this. What do you get? Come on. The formula of the compound formed from Mg plus 2 and Cl minus. Hope this is clear. The valency of magnesium is 2 and the valency of chlorine, Cl minus, is 1. So the formula comes out to be MgCl2. And now go for this. The same Mg plus 2, now with this. What do you get? You write it here. It is going to be MgOCl taken twice. I hope you got my point. You know, this cation with all the anions that you write here. Yes. Take it this way also. Then take it this way again. So with this cation, you write the formula for all the anions. With all the anions, you club this. Okay. Hope you all got my point with this. So this is how it goes, right? Come on. You make a very big table. That will be very interesting. And you also get too much of practice. So this is what I want all of you to make and see the clarity that you get on the formulae of chemical compounds. Remember, writing the formulae of chemical compounds is a very important. We are actually going for ABC of chemistry, which deals with the utmost basics of chemistry, without which you cannot just move on in chemistry. So these are all very important, right? Now, after this very interesting concept, let me just give you some question. Coming to the first question, see the way questions are asked on the formulae of radicals. Check this out. You know the formula, the question is formula of chloride of a metal. Chloride of a metal M is MCl2. Formula of its phosphate is. This is how they'll be asking questions. Very simple, very simple. You know, they have given the formula of the chloride of the metal, M. And they're asking the formula of the phosphate of the same metal, M. Let us see how to solve this. It's very simple. Listen to me carefully. You know the formula of metal chloride is given as MCl. Now from this we should actually get the valencies of M and chlorine. Very much easy. Cut it first. As cation and anion. Once it is cut into cation and anion, if there is nothing here, you just write one. Of course, you know this. Now, you know this one is of course the valency of chlorine. I mean the charge that is present on chlorine, it gives us the charge present on chlorine. And this too gives us the charge present on metal. So what is the charge present on metal now? 2+. Because in general, the cation is written first. Taking this 2 into consideration, you write the formula of metal ion. That comes out to be M+2. Look at this. This is the formula of your metal ion. Now, coming on to the second part, that is the formula of chloride ion. We can simply write it as -1, say 1 minus. Got it? Now the formula of chloride ion is, of course, this. From this, it is very clear that the formula of metal ion is M+2 and the formula of chloride ion is Cl-. Simple. Take this here, take this here. Right. Now, because they are asking you to write the formula of the phosphate of the same metal, consider this now. Take this into consideration. Come on. The same metal ion. Now club it with the formula of phosphate ion. Only thing is, from the given formula, we actually got the formula of the metal ion. Right? And now it is very easy. Just like we solve, we write the formula of chemical compound, isn't it? Now this is the charge present on the metal and this is the charge present on phosphate. But of course, you should know the formula of phosphate ion. Otherwise, you will not be able to solve. Come on. Formula of the valency of the phosphate is 3. That's it. You are done. Formula of the phosphate of the metal can be written as M3PO4 taken twice. Hope this is clear. Check out this once again. See, from the given formula of the metal chloride, we have actually got the formula of metal ion. Just taking this over here and this over here. Right? Once the formula of the metal ion is obtained, just combine it with the formula of the phosphate ion, which you already know. So that is how you get the formula of the phosphate ion of the same metal. Okay. Now, let me give you one more of the same type. Okay. Formula of biphosphate of a metal is this will be very simple to you. Biphosphate of a metal is MHPO4. Formula of its arsenite is very simple, isn't it? Formula of the biphosphate is given. Formula of arsenite is what they are asking. Let us just see. Biphosphate of the metal has the formula MHPO4. Then they are asking the formula of the arsenite of the same metal. Come on. You know, here it is little confusing. You should actually know the formula of biphosphate ion. Hope you know this. First cut it. Write the formula of biphosphate. The formula of biphosphate is HPO4 minus 2. Don't just get confused with the given formula and just take one here and one here. No, it is not. You need to be more cautious. The formula of biphosphate of a metal is MHPO4, but don't simply take HPO4 minus 1 because the formula of biphosphate is HPO4 minus 2. Now, when the charge on the anion is minus 2, obviously the charge on cation would also be plus 2. I mean, the magnitude of charge would also be, magnitude of charge on metal would also be the same 2. If it is 2 minus, then obviously it will be 2 plus. So now you got the formula of your metal ion again. Consider this. Right. Take that metal ion formula, club it with, combine it with arsenite. You know, arsenite is ASO3 3-. Right. Come on, write the valence. It's very simple now. The valency of metal ion is 2. I mean, valency of metal ion is 2 and the valency of the arsenate ion is 3. Come on, take a crisscross. M3 ASO3 taken twice. See the way I've written the formula. That is what I told you. You need to be very clear while writing the symbols. It should not be this way. M3ASO3 taken twice. What is that? Never ever go for this. See the way I've written. Okay. So that is about solving the problems of this different variety. Let me just give you one more. You know, the formula of oxalic acid is H2C2O4. Formula oxalate of a trivalent metal is. Very interesting. They have given the formula of oxalic acid, from where you have to get the formula of the oxalate and you have to combine it with a trivalent metal. Let me show you how to solve this. You know, okay, before doing something, you just cut it first. And we know very clearly that this too is the charge that is normally carried by oxalate, right? Now, if that is the case, then this one must be the charge present on H. Yes, of course, we know that hydrogen carries +1 charge because it belongs to first A group or the first group. So this is how you get the formula of oxalate ion. Now you got the formula of oxalate ion, which is very clear. Say this is the formula of your oxalate ion. Of course, you know it even before this also. I mean, even before cutting this also, if you know the formula of oxalate, of course, you can take that and you can combine it with the trivalent metal. Come on, let us combine this with the trivalent metal. What do you mean by trivalent metal? Metals generally form cation. So take it as M3 plus because they say that it is a trivalent one. Yes, the valency of the metal is 3. It's a trivalent metal. Come on, combine this with oxalate. All right. So what is the valency of oxalate ion? 2. Very simple. Okay. Now the formula of the oxalate of the trivalent metal can be given as M2C2O4 taken twice. Is that okay? M2C2O4 taken thrice is the formula of the oxalate of the trivalent metal. Got it? So this way, you have to solve questions on formulae. So if you are familiar with the formulae of the radicals, I think you can easily solve such questions.